Your shaded part right here is your feature. Okay, so at MMC, it's 0.15. Then your pattern locating feature is a parallel zone, okay, of cylindrical, and it's at 0.6. Okay, there it is in the feature control. Here it is drawn out for us. So the hole can be oriented like this, which dictates its position by its angular shape. It can actually end up drilled that way in an extreme situation. And as long as that feature falls within the pattern, which the pattern can be located, as long as it's 35 millimeters apart and 20 millimeters holds the actual zone. So anywhere it falls in there, it's going to be 35 millimeters apart. So you're controlling the feature itself, and then you're controlling where it lands within the pattern. So here's the pattern circle right here, and then here it is down this way. Okay, so the holes, the pattern is held at 35, and so the hole itself, okay, is 35 millimeters apart, must be, but it can be inside of that circle anywhere as long as they're held 35 millimeters apart. So, it's pretty goofy looking, isn't it? That looks like a really bad part to me. All right. So once again, they're using some extreme numbers here to show how they actually relate to one another in the real world. Of course, we're going to try and hold these holes as close to the center and more, closer to the pattern, of being across from each other, being parallel, and being perpendicular. So trying to, this is the basic perfect part that we're after. So that's how strange a shape it can become with this specification. So it's very important to control, be careful what's specified right in here so that you achieve what you're after. I really doubt that this would be allowable in the function, a real function of the part. Okay, now feature relating control must remain as a group perpendicular to the primary datum and parallel to the secondary datum. Okay, so let's look at this. Tolerance applied with two datum references in the lower feature control frame entry. Okay, so now we're able to control it and create this parallel zone, okay, that they must be with each other by specifying this. So that makes it look a little more controlled, doesn't it, by doing that. Okay, two single segment positional feature control frames. We display two position symbols, each in a separate compartment. Okay, like this. All right, we specify pattern locating control in the top, single datum reference in the lower half provides orientation, and then a double datum reference provides orientation alignment for the feature, and then offers tighter relationship of the holes within a pattern, and a pattern locating zones and feature relating zones must remain same distance from secondary datum. Alright, so when we look at this and we've got two positions specified, it's making us look at it as single segment. So we can see we have a little tighter control. We're controlling based on this center line right here and keeping it on that center that's 18 millimeters away from B, so that the pattern stays within this location. So it's a little tighter control. Then we have composite positional tolerancing applied to circular patterns. Okay, using a basic diameter and a basic angle. Feature relating zones located partially or totally within boundaries. Okay, feature relating zones are located partially or totally within the boundaries of our pattern. It's held perpendicular to the primary datum and controlled as a group by basic dimensions. And the feature axes must fall within both zones. So our feature axis has to be within both of the zones that we establish. Okay? Kind of like the other coordinate method. So here we have that part we saw earlier. We have one single position tolerance, so it's considered all together. The actual feature axes must lie within both zones. Okay, so here's our part. There's the center of it. It has to be within this pattern locating zone, and the actual manufactured hole has to also fall within the feature zone. Okay, so we look around through here and we've got a 0.3 at MMC and a 0.8 at MMC. So we're showing our MMC, our minimum restrictive specification. So you can see it's kind of difficult to understand, but you got two center line circles, one representing the actual hole where it actually ends up, okay, and then the other one is representing the pattern, okay. So you have a center circle of the actual produced part, and you have a center circle representing how they're related as a pattern, okay, and allowed to have different tolerances. Creates this kind of control. So basically we would create a pin arrangement to check this part that would subtract the pattern and the feature control frame at its MMC, and if that diameter at MMC, which would be the hole at its smallest, okay, so it'd be 8. Alright, so if it fits and we create actually a master part that mates up to this, that is off center its maximum amount, okay, from datum axis B, and if that master part slips into that manufactured part, it's a good part. We can easily check it that way. Then we can have two single segment tolerance applied to circular patterns. This allows locating pattern, locating, and feature relating zones from common datum axis, and displays a positional geometric characteristic symbol twice, and lists datum axis in both halves of the feature control frame. The top half of the frame controls the location of the features, just like the other, and then we add slot and tertiary datum to pattern located control to provide orientation of the pattern of holes. The lower portion of the feature control frame controls the pattern of features related to each other. So here's that situation. We have this slot, a notch, that's going to locate this part against something. And that center plane of that slot becomes our datum center plane C. Okay, so our pattern locating is related to C. Our feature relating is related to A and B. B is the center of the hole, and of course A is the bottom of the part, or the top of the part in this case. So considering all of that, your material condition requirements in composite positional tolerancing, the composite and two single segment feature control frames must have same material condition. You can't have one with a circle L, one with a circle M. And the datums must be in the same order of precedence. So we can't mix that up. We have to, since they're a pattern, they have to be considered related to datums in the same order. Coaxial features, anything that has a common axis like holes and counterbores. So when a tolerance is the same for both features, positional tolerance zone diameter is the same for both features relative to specific or specified datums. So the feature control frame appears below the note. So let's see. Let's flip to let's see if I can do that. I may have